Welcome to class number 70. I already told the sequence of the questions here. You can follow Roman 5, 3 I am doing bookwork first. Actually, last time I told you that bookwork numerically will do. No, I decided first finish the bookworks. It is better in a stretch do the numericals and also in a stretch do shortcuts so that it will become mix up. Suppose some people are there who does not want all lengthy calculation, they can skip. But even for them, understand the concept. At least go through once. It will be clear. So when something is going to be clear for you, lengthy, understand and leave it. Go for shortcut. So uniformly varying load, 0 at center and maximum at supports. That is exactly other way of last time. See, last time like this. 0 at the ends, maximum center. Now 0 at center and maximum at ends. Actually, this is not a regular type of loading, but standard case it is there. I will consider it. Let C be the center. First reaction calculation as usual. Symmetry VA equal to VB equal to total downward load divided by 2 half into L by 2 into W into 2 is the total load divided by 2 WL by 4 will come. Now to draw SFD BMD. Note I am going to dictate something now. I will explain it here. You write it. Given in the class. No space right here. Two options we will go for. One of the option. Take a section XX here, X from here. Take XX, X from there. Then when you look this side, you are going to get UVL in the form of trapezium. So lengthy calculation. But systematically you will solve. See, every question when you solve systematically gives you perfect knowledge and concept. Shortcut will help you only if you know the basic concept. So that way you will solve. Then that is one option. How to find WX I will tell you here now. Second option is something special. Very, very easy. You write there, very easy. After finishing option 1, I will go to option 2. At that time, I will explain that one. Right now, suspense. See, right now, suspense means what? I will better tell little later only. So now, option 1 continued. Consider section XX, one XX between A and C at X from A, one more XX between B and C, X from B. This expression, whatever you get expression for this XX, valid from A to C and this one valid from B to C. But like last time I told you, you can use symmetry. So when you do bending moment, see, symmetrical, both are sagging and hogging. So it will become exactly same that side. But shear force not that way. Left side up positive means right side down positive. So what will happen? I already told you, if symmetrical loading is there, perfect symmetry is there, BMD will be symmetrical, but SF will be anti-symmetrical. Whatever you get upper side here will come lower side. Or if you get positive sign this side, you get negative sign that side. So that we will use today. But I will write systematically that one. Okay, now start. Let W suffix X be the intensity at XX. From similar triangles, W divided by L by 2 equal to W suffix X divided by this distance, L by 2 minus X. Or your WX will become, this 2 will go to numerator, 2W by L into L by 2 minus X. Or directly stand here, W by L by 2 into L by 2 minus X. W by L by 2 means 2 will go to numerator. This all told. And one more thing. Since it is a little lengthy one, I will not solve in front of you. It will take a lot of time then because simplification will be there. Lot of simplification. You have to, even I have to struggle somewhere. Struggle means not concept struggling, simplifying struggling. Therefore, I will write and explain better. Anyway, this is only for those who are interested in concept. Others can go for option 2 and majority I know will go for shortcut. That is very easy. That all shortcuts in a stretch I will do it. Okay, now I will fully write the calculations here and explain and complete this option 1. But I will explain so that those who are serious, they will follow thoroughly and understand correctly. I wrote everything. I will briefly explain. Shear force here, for shear force. Look this side. Plus WL by 4 minus this much load. This already earlier thoroughly explained in one problem where I took x from left hand, unnecessarily from left hand, still we got the answer. We got trapezoidal part there. So minus this much load means this much area. W plus this ordinate divided by 2 into x. I wrote here. Then simplify. WL by 4 minus W by 2 I will push outside. Becomes what? 1 plus 2 cancels. W has gone outside. L cancels. 1 minus. See, 2 times minus x by L. W has gone outside and by L will come into x, or WL by 4 minus W by, I will take once again from your L outside, W by 2L into 1 plus 1 is 2, 2L minus 2x into x, or WL by 4 minus W by L, because 2 and 2 will cancel, W by L into Lx minus x square is the expression for shear force for section XX between A and C. Parabolic variation, second degree, x varies from 0 to L by 2, thoroughly told. I made a note here, see, for information. Substitute x equal 0, shear force at A will become plus WL by 4. Substitute x equal to L by 2, simplify it, it will become 0. It has to come 0 because symmetrical loading, maximum BM at center, or see, whatever is this upward force will be equal to this downward force, so shear force has to come 0. 0 came. So note, for x equal to L by 2, we got SF equal to 0. So there is no point in the usual calculation of where shear force is 0, that locating the point. Why you should locate a point when you got shear force 0 at center? Over. SFD for AC will be at A, WL by 4 positive, at C 0. Remember, you should make a note. At A, intensity of load is maximum, so maximum slope. At C, intensity is 0, so 0 slope. See, if you remember last time, I will tell, or not now, later I will tell, not now. I will compare the two SFDs of this type of loading and this type of loading. That time I will tell. Now, no point in wasting time for section XX for CB. This is actually B. See, okay, print mistake. I told print mistake. Okay. XX from B, because same ditto value will come, but only thing here, see, plus minus, here minus plus. So just you can write, because of symmetry for that section, shear force equal to whatever you got here, change the sign. Minus WL by 4 plus this term, that is minus become plus. Substitute x equal to 0, minus WL by 4, x equal to 0. So SFD will be 0 at center, this is center C, and maximum here of WL by 4. And here maximum intensity, maximum slope, here 0 intensity, 0 slope, SFD for BC portion. Now we will go for BM calculation, get it, and then finally close it, and traditional solution we complete. Then you go for the other option, which is very simple actually. I wrote everything because usually people will tell, sir, this is not required. Yes, okay, but at least show interest and understand. BM here, WL by 4 into x positive minus moment of this load, first total load, sum of the two parallel sides divided by 2 into distance between the two parallel sides is the total load into CG from here to here is this side plus twice of this side divided by this side plus this side into distance between them divided by 3. Those who are serious, those who understood from earlier, they will understand. Others can leave it because there is no point in wasting time unnecessary for high school mathematics now. Now see, I simplified this one. Finally, mx comes this much. Remember, parabolic of third degree. In case any mistake is there, correct it. But usually mistake will not be there because result will tally. Now, substitute x equal to 0. You get BM at A0. Substitute x equal to L by 2. You get BM at C equal to WL by 4 into L by 2 minus 1 by 6L into 3WL into L by 2 square minus 2W into L by 2 cube. Now, simplify this one. Finally, you get W square by 24 positive. Therefore, BM at center equal to WL square by 24. Okay. Now, not here. Now, as usual, see, it really not required. Lastly, I'll write here. Lastly, we want maximum BM. You know the answer. Maximum BM is at center because that is the point where shear force 0, but still mathematically, for mx to be maximum, dmx by dx equal to 0. So differentiate mx with this mx with respect to x and equal to 0, you get finally quadratic equation of this form. See, all 6 will cancel here. Simplify this one. That is 0. Therefore, solution is x equal to minus b plus or minus root of b square minus 4ac divided by 2a. Substitute, you get L plus or minus L minus 4 into 1 into L square by 4. See, this is actually some ink spreading. L square minus 4 into 1 into L square by 4. 4 cancels. L square minus L square is 0. L plus or minus 0 by 2. X equal to L by 2. See how beautifully answer comes. It has to come. So, x equal to, note, you write here. We know that, or you can write here. Therefore, see, 1 minute. Therefore, BM is maximum for x equal to L by 2. X equal to L by 2. That is at center. And right, at center BM already calculated. See, already calculated. So, no need of substituting once again. And therefore, BMD for AC will be 0 here. WL square 24, parabola of third degree. Right? Already told earlier, still to understand. Parabola of third degree sufficient. This is BMD for AC portion. Now, just I will see the available space there. Finish here only. Okay, I can manage in the down space. Just a note. See, there is no point in wasting time for this section XX because, see, WL by 4 into X positive. WL by 4 into X positive minus bending moment is symmetrical. So, you can write here for BC portion X from B, your MX equation will be sagging positive equal to, see, WL by 4 into X minus 1 by 6L times 3WL X square minus 2W X cube. Then you can write that is same as that for XX between A and B. That's all. Therefore, no need of wasting time here. You can write here. Therefore, BM at B equal to 0 and BM at C equal to plus WL square by 24. So, BMD for BC will be B here, C here, WL square by 24, parabola of third degree parabola positive. This is a BMD for BC. Write that extra part if you want. And lastly, I will draw SFD BMD. You can see I increase the space. That means reduce the size. Size means while writing, size will get lesser because I want more space. Okay. Lastly, I will draw SFD BMD. Okay. Now, lastly, SFD. See, WL by 4 here, WL by minus here you got, plus. Now, intensity maximum slope, and here 0 slope. See, it will come this way and it will come how? This way here. Now, make it more neat. See, how it will come now. See, correctly I will draw now smoothly. When you reach this point, either side slope should be 0. Why? 0 intensity. So, it will come. Then, once you reach here, then it will turn this way. See, this is the shearing force diagram. Little if you have tangent here, both are 0. BMD This is slightly, okay. That's all right, no bother now. Okay, reasonably okay. W square by 24. This is a center here, shear force 0, plus and minus. SFD and BMD. Again, little later, or all the types of loading, I will give one extra class I will tell the variation, so many principles I will tell. If confusion is there, after that come back here and go through once again. SFD and BMD over now. So reaction A, this is B, this is center C. C is the center. Over. Complete. Now, that option 2, I thought I will carry out in this class only, but already taken more time. So better in a separate class, that is next class 71, I will take up that option 2. Actually very, very easy, but little concept required. Okay, we will meet in next class, that is class number 71.